So now that we have a sense for the pressure of the atmosphere, let's talk about now leading into some weather maps and looking at weather maps. So oftentimes on a weather map, you're going to see if this is, I totally butchered this, but this is my west coast. Okay, here's Florida, here's Mexico. Oh my goodness, that's terrible. But oftentimes on a weather map, you will see these highs and lows, highs and lows. And those are actually different regions where we have a high pressure and low pressures. And these actually create some weather patterns, and these are actually called horizontal differences. Okay, not vertical differences in pressures. Now, why do those differences, why do we get those kind of sometimes alternating high, low, sometimes not necessarily alternating? But there are three main reasons that actually we can get these differences in pressure at the Earth's surface. The first one is differences in temperatures. So here we have this cold air. Okay, cold air is more dense. So here at the surface, it's more dense, so it creates a high pressure. Warm air is kind of fluffy at the surface anyway, so this warm air actually creates, if it's fluffy, it creates a low pressure. Okay, so that's one way to get differences. Another way is actually has to do with moisture, and we've talked about how different chunks of air can have different humidities. We talked about different air masses. Chunks of air that dwell over the ocean become moist. Okay, if their source region is over land, they're dry. And like I said, this is a little counterintuitive because we think that when the air is high humidity, it's hard for us to breathe and the air feels very dense. But as it turns out, moist air actually is less dense. So moist air is associated with low pressures. Okay, dry air then is associated with high pressures. So that's another way you can get a horizontal difference in pressures. And then the last one is the air coming together or is the air leaving? And I think this is kind of a cool concept. I kind of liken it to if you throw candy in a playground, okay, in one region, you're going to have kids converge, okay? And if kids converge, you're going to increase the density of kids there. So that's actually going to create a high pressure. Okay, so converging air creates a high pressure. If one of those kids eats too much candy and throws up, okay, you're going to have the kids scatter, okay? They're going to actually create a low pressure there. And so that also if you have air that is scattering from a region, then it's creating a natural low pressure there. So those are three ways that you can get high and low pressures at the Earth's surface. So I don't know how much, I wanted to stick this in there, that if you have one of these gizmos, this is actually a barometer. It's what we call an aneroid barometer. It means that, it's kind of in a closed chamber that kind of can be squeezed and flexed with the pressure. But this dial, if you have one of this, you can actually kind of twist this dial back and forth. That's for you to twist. And then what you do is see this black right here, this black line right here. This actually is moving relative to the box being squeezed or let go. So that moves from pressure changes, and then this actually is what you move. So what you do is you set the little gold thing on what the current pressure is, and then you come back a day later to see how the pressure has moved. And if your pressure has increased, okay, so if this black thing went over here, okay, then that means you can expect clear or clearing skies. If you come back later and it's like it is now actually, where we have falling pressures, can you see where this is where it was set and we have pressures that have fallen since then you can expect that we'll have clouds or precipitation coming. And if you come back and actually there's no change, they totally line up, so your black is under your gold, then whatever conditions you have will continue. So again, I'm not sure. I think I'll get into at the end of this part why this is the case. But with rising pressures, clear skies with falling pressures, cloudy and precipitation, and with pressures not changing, then you get to have the weather you get to have. It's going to continue.